All right, so the first, I'm not sure what number this was, but they're asking you to find the values for W, X, Y, and V. One thing I want to kind of commit to your memory is in WebAssign, when they give you multiple options or multiple parts that you have to solve for, just because they put X first doesn't mean that in your problem you're going to be able to solve for X first. Does that make sense? Okay. My suggestion to you is kind of completely ignore the way that they structure the solutions and how you type them in. I always go to my problem and I say, okay, what can I figure out? Okay, and start trying to figure out all that I can, and then once I have things filled out, then go and pluck those off and put them in the appropriate spots down here in the answer. Does that make sense? Okay, you're gonna find out there, and it might work this way where you can do it by order, but there will be undoubtedly questions throughout the year that you cannot do them in order. Okay. 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 So if we look at, let's see here, and I think for me, obviously, and I said this before, you guys can't do this, but I can kind of white things out, right? So let's see. I'm just going to concentrate on one set of parallel lines. There we go. So let's just look at maybe the top parallel line and the bottom parallel line. So I'll get rid of that one. And when I get rid of that one, it gets rid of that. That's gone now, right? Angle X here is gone because I don't have that second side to help make that angle. Get rid of this one. So now angle V is gone and angle of 88 is gone. Okay. So those are my top parallel lines. Let's look at just one transversal. Okay. Now you guys said why you couldn't figure out. So let's get rid of this transversal. And does that allow you to make a conclusion about W? W is 22, right? Okay. Alternate interior angles. And that's my suggestion to you guys. Obviously, like I said, you guys can't white things out, but can you come to a piece of notebook paper and say, okay, look at the top line, let's look at the bottom line, and let's use this segment here as my transversal, and then say, okay, well, what W would have been there, and 22 would have been there. Can you redraw things? Okay. So just kind of keep that in mind as we go through it. A lot of times in this class, you're going to need to maybe redraw a picture 2, 3, 4 times using the pertinent information, the information that is useful to you, and eliminate the things that are kind of cluttering the image. All right, so we did that. Now let's look at, so I was looking at top and bottom, and that gave us W and Y, and we knew we couldn't find Y. So let's now look at the left and right parallel lines, yes. So get rid of those. Let's look at which transversal you want to look at. It doesn't matter. If I look at, let's look at this one here. What does that tell me X is? 88. They're alternate interior, right? So X is 88. What does it tell me about V? Okay. So we've got a cluster of alternate interior angles that are going to allow me to find X to be 88, W to be 22, and V to be 44. And you said finding Y was then the trick, right? And I think it's because we've looked at this transversal and we've looked at that transversal for both sets of parallel lines, right? There's still a series of transversals that we're missing. If we look at wiping that away, well, sometimes it'll disappear. If I do something like that, okay, would you agree that this line and that line are parallel? Yeah. Is that a transversal? By definition, it intersects two parallel lines, right? So it's transversal. So what kind of angle would this green angle, which is made up of x and y, and this angle here that's made up of 22 and v, what types of angles would those be to one another? Same side anterior. They are, if I look at my kind of generic picture here, they're that angle there and that angle there. They're same side anterior. So same side anterior should be supplementary, right? Okay. So we're going to add up to 180. So all we're saying here with this picture is that that green angle right there, which is this one, is just made up with these two smaller parts, x plus y. So we'll say x plus y plus then these two, 22 plus v, is equal to 180, right? And now we know what x was. What did we say x was? 88? Okay, so x was 88. Y is what we're looking for. And v was 44. So then we can go ahead and say, okay, well, that's what's 110, 154. So then y is going to be 180 minus 154. Does that make sense? Okay, so that's one of those things, and I think you can kind of maybe argue that that relationship's kind of hidden in there, right? And only through redrawing, covering certain things up, that we can really see that kind of pop out at us. And that's one thing you're going to hear me say a lot throughout the rest of the year is when we look at questions like these, they're kind of like brain teasers or puzzles, or if you're a person that likes doing like riddles or mental puzzles, you'll probably enjoy some of the questions that you see in this class because they're very similar to that. Okay. This one was kind of like the question we finished class with yesterday, but not as involved because the last step isn't that we saw yesterday wasn't required here. They're starting off with parallel lines, two sets of parallel lines, and they want you to prove that angle 1 was congruent to angle 3. Now they're only asking you in this question to give the reasons. So there's drop-down windows over here, but I want to do the whole thing. So I got A parallel to B and C parallel to D. That's our given. Next thing I want to do is say, now I've got parallel lines. Let's look at just one set of parallel lines. So let's focus on maybe that line there, and actually, because I want to make sure. And now they, in the homework, said angle 2 is congruent to angle 1. If I look at angle 2 and angle 1 here, why are they congruent? Why are those two angles congruent? Not vertical. If we do this, does this help? They're alternate interior. Okay. So we're going to write that alternate interior angles are congruent. Okay. The next thing that they write is that, actually in the predefined statements, they do it this way. So they write that part as step 3, which is fine. So they put a given in, and you don't have to select anything on that. That was already filled in for you. And then in step 4, they say angle 1 is congruent to angle 4. Okay, if I go back up here, look at angle 1 and angle 4. Look at the lines that are making up angle 1 and angle 4. So those lines are just creating clutter for me. What do you know about 1 and 4? They're corresponding, right? Okay, so that's why they're congruent. Angle 1 is congruent to angle 4. Oh. So corresponding angles are congruent. Okay. Now, look at statement 2 and statement 4 together. If I put them in line, I get angle 2 is congruent to angle 1, and angle 1 is congruent to angle 4. What can I then say? What's the new argument that I can say? Good. Angle 2 is congruent to angle 4. That's going to be your transitive property. Okay. It's the idea that those two things, angle 1 and angle 1, can overlap. They're the middleman. So then we can cut that middleman out, and we're left with angle 2 is congruent to angle 4. That's the transitive property. Okay. Another way of doing that, and I kind of neglected it here, but as we're going through here and we write these congruencies down, we said angle 2 was congruent to angle 1. So we should have done this. And then we said angle 1 and angle 4 were congruent, so we should have put that in. Okay? And now we've got 3 congruencies, and we've specifically talked about these two and those two, but we've never talked about that one and that one related to each other, right? But now we can because we see that they have one mark in them. And that idea is if I give you a handful of things that are, you know, they're all the same, they're all congruent, you should be able to take any 2 of them out and say any 2 of them are the same or congruent. And that's what we're doing there, and that's the transitive property. Does that make sense? Okay. Are there any questions that you guys had, any problems in there that you knew that were, other than those 2 that were maybe causing an issue or confused about? Hannah? Okay. So let me cut that one out. So something like this. Okay, so we got 2 parallel lines, right? What I always like to do when I see shapes like this, that I like in my mind to see that picture all the time. If I can see that picture, I am so much better at determining alternate interior, alternate exterior, that kind of stuff. Okay? So I want to rewrite this image here so that I have that. So what I always do is I focus on my parallel lines and I highlight them. Okay? So I'm going to take my parallel lines and highlight them. And I extend everything beyond what the picture is showing. And then I know I'm going to use 7x and 13x. Those are the things that I have information about, right? Those are the angles I have information about. So I'm going to highlight then the line that helps make the 7x with my parallel line and the line that helps make the 13x with that parallel line. And that line would be that one, right? That kind of makes sense? So now if I can see that, what would you, if I take the picture out, take the parallelogram, I guess it's actually a trapezoid. If I take that out, what would you know about that angle and that angle in regards to one another? What would you name them? What would their vocabulary word be? Same side interior, okay? So if they're same side interior angles are what? Should be supplementary to one another, right? So we should be able to take 7x plus 13x and set that equal to 180. 20x, 180, xn has to be 9. And then they ask you, okay, well, what's the 13x angle? What's the 7x angle? So then just plug that 9 back in and evaluate those things. When we get to Chapter 6, we'll talk about, based off the information they give me, even though this looks like a parallelogram to us, right? Okay? When we get to Chapter 5 and 6 and we start learning the properties of parallelograms, we will actually learn that this here is actually a just bare minimum we know it to be a trapezoid, okay? We don't have enough information there. Even though it looks like a parallelogram, we don't have enough information to guarantee that, okay? And that's one thing that you might hear me say throughout the year. Looks can be deceiving, okay? You guys have all read like articles about people that have been like, they live like homeless people or they are homeless people, but then when they die, they've left millions of dollars to some institution. So they didn't live like they had a lot of money, but they had a lot of money, right? So the looks of that person might have been deceiving to their wealth. these looks here, it looks like a parallelogram, but that's deceiving. The information given doesn't tell me it's a parallelogram. And that's something that this class is going to try to get us to focus on. For instance, if I give you something like this here, if I go, let's say I've got a line of like y equals 2x, let's go plus 1, and I go y equals 2.00001x minus 3. Oh, x minus 3. Do those two lines look like they're parallel? Okay, do you remember what the algebra said last year about lines being parallel? Why is it doing that? Well, I don't know why GeoGebra is doing that. Let's do this. 2.0001. Okay. There we go. All right, so those look parallel to our naked eye, right? But a slope of 2 and a slope of 2.0001, your eyes can't tell a difference in that, okay? But because the slopes are different, and that's what the rule was last year, if the slopes are different, then the lines are not parallel. If the slopes are the same, they are parallel, okay? So I will be able to determine where these things intersect. Hopefully GeoGebra has, because it's pretty far out in the x direction, see if GeoGebra will allow this to happen. So there is the actual point that those two lines intersect. Does that make sense? Okay, pretty large in the x and y direction. But looking at it right here, the looks are deceiving. Okay, if I did something like this, if I actually had it as 2x minus 3, and I asked where do they intersect, you see now it says question mark because they don't. Everybody kind of understand that idea? So looks can be deceiving. We want to go off the information that is provided for us. And that's just, I mean, it's not a huge issue in this question, but that is something that is prevalent through the rest of the course. Anything else? Yes? 15? So another thing to think about as we're kind of on the topic of how you're going to see questions show up in this class, kind of seems like, you know, you go back to like Algebra 1. If I give you an assignment in Algebra 1, let's say that we're solving equations, and I give you 15 questions in the homework, pretty much all 15 questions are very similar, right? Okay. Are you starting to see maybe in geometry that every question is unique? Every question is a little bit different, but there should be some kind of an overall kind of common undertone to each question, okay? So there are some similarities between this question here and this one here, but maybe at the onset we don't really 100% recognize them. But the way we approach them could be similar. I see the parallel lines again, so I'm going to highlight those. I'm going to focus on that line and that line, okay? Now if I do that, I've got two transversals, okay? We've got this line here being a transversal, and we've got that line there being a transversal, correct? Okay. Now, only one of those is got angles attached to it that have quantities or representations. So my thought is initially, and this might change later on, but that transversal is probably not very helpful to me. So I'm going to focus on this transversal, and I like to extend it. But 3x minus 11 is talking about that yellow angle there. And x plus 39 is talking about that yellow angle there. What types of angles are those in comparison to one another? Corresponding. And corresponding, if the lines were parallel, which they are, corresponding angles had to be what to one another? Congruent. Congruent, okay? So corresponding, congruent. So we got 3x minus 11 should equal x plus 39. I'll subtract 2x from both, or sorry, x from both sides, get 2x. Add 11 to both sides, get 50. So x should be 25. And then it asks you to substitute back in and find what those values are. Once you substitute back in and find that one, and you substitute back in to find that one, they should be the same. In this case, they'll both be 64. And that then is kind of a built-in check. Does that confirm that they should be equal because they're corresponding? So I think that's something that with practice, with exposure to more and more kind of authentic or unique problems, that you start to realize, okay, let's take the picture, let's cut part of it away, let's redraw it, let's hide some aspects of it to declutter things, and it might make the necessary observations a little bit easier. Okay? I've been getting phone calls all the time about doing surveys and voting for presidents, and that's what that was. Anything else on there? Any other questions you guys might have questions about? Yes? Oh, yeah. This one's always questioned every year. All right, so again, I want to highlight the segments or lines that are parallel. So we're going to look at that one and that one, right? Okay. There's a transversal here. There's actually two. One of them is beneficial, one of them is not. Okay. So if I highlight that one, and I'm going to highlight purple. Highlight that one. Which one, the purple one or the blue one, do you think is beneficial to us? The blue one. Why? Okay. So the blue one has identified angles, right? There are angles on the purple one, but there's no description of what they are. Okay. So the blue one's going to be of benefit to us. So this is just this purple one's an extra one, just there, meant to confuse you. Okay. You guys remember in like elementary, might have been later in middle school, you first started doing story problems, and before you even did a story problem, like the process was, you're gonna read stories, and then you're gonna like highlight the things that are important and highlight the things that are not important. That's exactly what we're doing here. Trying to decipher the things that are important and the things that are not important. So we can actually then focus on the necessary geometry, okay? What do you know about some things up there? Okay, x and 11y are congruent. So x should equal 11y. Everybody okay with that? What's another relationship that you, because that's two variables, right? And if that's two variables, I can't solve numerically for either of them. Okay, this one is solved for in regards to x, but I can't solve and know what x is as a degree in terms of a number. Dax? X and what are? X and y. So I say x plus y is equal to 180. Okay? You guys remember what this is called? If I have two equations with the same two variables, what's that called? You guys remember hearing this phrase last year? System of equations. So the word system, just a fancy way of saying group. Okay? It's a group of equations. Now there's, group is a vague word. System actually says it means group, and it refers to the idea that you've got equations that have the same variables. Okay? So I got x and y here in this one, x and y in that one. Those together then can be used to solve for x and y numerically. If x is equal to 11y, can I come over here and where I see that x, replace it with 11y? So I have 11y plus y equals 180. So 12y equals 180. Y is going to be 15. And if y is 15, then x is going to be 165 when I plug that back in. That help? So here's the kind of conundrum with geometry. Geometry comes after what course? Algebra, okay? So the assumption that is made, and this is holistically through all math courses, is that we have mastered all of algebra, which I know is probably a bad assumption, right? Okay. Now we're decent at, and I'm not even put myself in that category. I'm decent at algebra. I can get better. Okay. No matter how good we are at it, we can always get better. When we do problems like this, okay, they are assuming that we have that knowledge from Algebra 1 of what to do when we get an equation that we can't solve for numerically, okay, for either variable, that we then try to generate another equation that has the same two variables, okay? And I think it's important for you guys to recognize that right now in geometry. So geometry requires you to, essentially the assumption is that we've mastered Algebra 1. So when you get to Algebra 2, what two classes came before Algebra 2? Geometry and Algebra 1. So what do you think Algebra 2 is going to assume that you've mastered? Geometry and Algebra 1, because it's going to use some of those concepts. Now, it doesn't use as much geometry as geometry uses Algebra 1, okay? But Algebra 2 will incorporate some geometry. When you get to college algebra, okay, so your fourth year of math, or some of you third year of math, it's going to incorporate all years before that, right? Okay. I've taught we don't have enough students right now to teach calculus, but in the past when I've taught calculus, you could see in like one homework question of like 5 problems, you could see components of Algebra 1, geometry, Algebra 2, college algebra, trigonometry, in all different areas of those courses inside just one homework assignment. Does that make sense? Because the assumption is that we've gained that knowledge and we're able to use it whenever. Now, terrible assumption, but it's there, and that's how things are developed. Anything else? I do not know that. I should know that, but I don't. All right, so what I want to do real quick is get into 3.3, which is proving lines be parallel. And what's going to happen here, it's not going to take us very long to get through this, because it is essentially everything we've already talked about with 3.2. It's just the converse of it. Okay? You guys remember what converses were? Okay. So yesterday we said, let's say here, we said if, I'm going to type something. All right, so yesterday we said if two parallel lines are cut by a transversal, then let's say alternate interior angles are congruent. That's what we said, right? Okay, that's an if-then statement, correct? Okay, the converse of that would be if alternate interior angles are congruent, then it's weird to word it as then two parallel lines are cut by transversal, but then I'm just going to say the two lines cut are parallel. Okay, so that ends up being true today. Okay, so it gives us a phrase from yesterday that is actually reversible. It's something that we can use both ways. Okay, so yesterday I said we had to have two lines to be parallel, and then we gained from that congruent angles. Okay, alternate interior angles to be congruent. Today, if I'm looking at this picture, if I'm looking at something like this, and you know nothing about these lines, you know nothing about these lines right here, okay? But I tell you this right here. What is the conclusion then that you can tell me about those lines? They're parallel. Yesterday you started off with parallelism, and you develop congruency with angles. Today, we're going to start with congruency of angles and develop parallelism in regards to the lines. Okay? I think if I was writing a textbook, okay, I would not have this as a section, and 3.2 would not have been a separate section. I would have taken these and I would have written them as an if and only if statement, okay, as a biconditional. I would have said if two parallel lines are cut by a transversal, if and only if alternate angles are congruent, okay, and that would allow me to incorporate basically both sections into one, okay. But that's what this is getting at here in this theorem, okay. And then this one, first one's talking about corresponding angles. It says if two lines in a transversal form corresponding angles that are congruent. So we're starting off with congruent corresponding angles. If that happens, then the lines are parallel. Okay? So here what they're saying, if angle 2 is congruent to angle 6, then your conclusion you can make is that line L and line M are parallel. Does that make sense to everybody? Okay. So if I look at this picture here, and I tell you that angle 1 is congruent to angle 2. Angle 1 is congruent to angle 2. That's what we know. What lines would you be able to tell me are parallel then? Careful, lines. A and B. So the idea is when you look at angle 1 and angle 2, I'm going to highlight the lines that make up angle 1. Would you agree that that line and that line make up angle 1? Would you agree? So I'm going to do the same thing for angle 2. Would you agree that that line and again line M make up angle 2? Okay, so I'm just trying to focus my attention there. That means that all this other stuff was useless garbage, right? Okay, so now angle 1 and angle 2, they're congruent. Are they corresponding? So we got congruent corresponding angles, and if they are congruent and corresponding, then the lines that make them have to be parallel. So which lines are the ones that are going to be parallel here? It was A and B, right? Okay. So that's just another one of those situations where we get a nasty looking picture, but once we focus our attention on the things that they're talking about, 1 and 2, and then the focus on the things that make up 1 and 2, delete everything else, it gets back to something a little bit simpler that we can make a conclusion about. All right, so the rest of this just simply talks about if we have alternate interior angles. So I'm able to show, in this case, angle 4 and angle 6 are congruent. That's going to lead me to line L and line M to be parallel. Okay. We have the converse of the same side interior angles theorem, which says if you are able to show two same side interior angles supplementary, if you're able to know what angle 3's measurement is and angle 6's measurement is, and they add to 180, then line L and line M have to be parallel. That's the only time that they're going to do that. Okay? So section 3.2 and section 3.3 are converse of one another. Okay? Which tells me that the rules I learned in section 3.2 are reversible, or the rules I learned in section 3.3 are also reversible. Okay? Same thing happens with alternate exterior angles. Okay, if I'm going to show them congruent, then the lines have to be parallel. Skip this. Okay, so what happens then in your homework? You're going to see practice questions that look like this, and they're going to say, for what value of x will make lines A and B parallel? It's ultimately the exact same thing that we have to do. That we did yesterday. What do they have to be? If they're going to be parallel, if A and B are going to be parallel, what's the relationship between these two angles that has to exist? They have to be supplementary. So these two angles, that one and that one, have to add up to 180, right? What you got? Oh.
Wait. Yeah, 30.
All right, so we got 2x plus 9 plus 111 should equal 180, right? So 2x is equal to 60. So x will be 30. Good. Okay. But is that really any different than what we did yesterday? No. Okay. We just don't know right off the bat whether they're parallel. But now that I know x is 30, it's going to guarantee that those two lines never intersect. Meaning then, if x was another number, if 30 is the only number that makes them parallel, what if I say, well, what if x is 10? What does that mean these lines are going to be then? Not parallel, okay? And one of the word that we use for not parallel is convergent. They're gonna converge on one another. They're gonna intersect eventually. What's the relationship here? To make A and B parallel, those two angles better be supplementary. There's same side interior again. So 3x plus 3 plus 48 should equal 180. Again, just to save time, I'll let you then solve that equation on your own. Okay, so they add clutter. They add things that make the problem get a little bit nastier. Okay, what segment, or sorry, what lines are we interested in here? Yeah. That's I know it looks like an E. That's actually a cursive L. So this line here, not doing anything for me, right? Okay. Now, is there a relationship? Do we have a name for that angle right there in comparison to that angle right there? Okay, so they're on opposite sides of the transversal, right? So they're alternate. Okay. Is one of them, so this yellow, oh, that's not yellow. This yellow stuff is the interior, right? Okay. Is one of them in the interior? Is one of them in the exterior? Okay, so that's an issue for us. We don't have a vocabulary word or definition that relates an interior angle to an exterior angle that are on alternate sides of a transversal. So there's no direct relationship here. But you can navigate this and still figure something out. If I look at just that right there, what's it? Okay, so that angle is 75. Okay? That angle is 75. So we can do it that way. Let's do it that way. Why is that angle 75? It's got to be a linear pair with 105, right? Okay. So now, what would you tell me about if we're trying to make L and M parallel, what would you need to know about that angle there in comparison to that angle there? That'd be what? They're alternate interior, so for the lines to be parallel, alternate interior angles have to be congruent. So here I would say 3x minus 18 equals 75. Okay? I'm going to put a 1 right there on that, because what I'm going to do is a different way. Did anybody recognize that they could have made this 105 come down here? Okay? So what would you recognize then about that blue angle and this green angle? They're supplementary. So could I say 3x minus 18 plus 105 equals 180? Okay. Are those two different equations? If you subtract 105 from both sides, you end up with the same thing, don't you, eventually? Okay. But the person that used this black equation used a different approach than the person that used the blue one, right? And that's the thing, as we go through the course, when we go over something in homework, okay, and you ask me a question about something, and I do that problem, and I see it one way, and I do it that one way. There might be 3, 4, 5, 6, 12 different ways of doing it. And if you see it a different way, let me know, and we can talk about it. Something that's going to maybe bug you at times. And I get this every year. People are like, he talks about one problem for like 55 minutes, okay? But it's because there might be 6, 7, 8 different ways of doing it, okay? And if I only focus on one way of doing it, there might only be one of you or none of you in this class that can do it that way or see it that way, right? But if I target all 6 or 7 different ways, now maybe I've given everybody an opportunity to see how to do the problem and connect with it that way, okay? We'll stop there. You want, which one? This one? Yeah, what's the answer? 31? Is that right? Okay. I'll open up 3-3 in Math Excel. And what is today? Wednesday? So that'll be due Friday.